When is the last time you listened to a podcast about web development, web design, and small business and didn't fall asleep? Yes, we cover web development, web design, and small business, but like actual human beings with personalities. If you're a beginner, we're not going to talk over your head. It's more like asking your buddy for help. We have guests, we have fun, and let me tell you, these two can get off on a tangent. Ladies and gentlemen, welcome to HTML All the Things Podcast. This is Matt Lawrence and Mike Curran.
That's right, everybody. We are back, and this is episode 213. We are just talking about golf. No, it's a joke. Mike and I had just had about a 1 hour, maybe a half hour conversation on golf after I just came in from golfing in the rain like a fool. Probably shouldn't be in the rain doing that, but wanted to golf, so away the road. But anyway, the actual name of the episode is What Can't JavaScript Do? So we'll be diving into things like what is JavaScript good at? What does it do well? What it doesn't do well? Some alternatives, all that stuff. So if this sounds interesting to you and you want to support the show, you can go check us out on that Patreon, leave a review rating on your podcast app, join us in our Discord server, or share this with your friends. And now, Mike, you wrote up this episode with love, I hear. So please, take it away.
Yeah, I think that is a good way to put it. Like, I do have a little bit of a love for JavaScript, so I will be biased. So if someone's coming in here hating on JavaScript, know that I'm coming at it from a place of this is what I use every day and I'm not planning on switching. So know that it's going to be a biased episode. You can switch off or you can listen to some reasonable and unreasonable arguments that I'm going to have. But
I really enjoyed the fact that I threw that love part in just randomly, trying to get you just to say something, and it actually ended up being a thing. So I really enjoyed that, actually.
I feel like after how many years? Like after 10 years of business together and over 3 years of recording a podcast, we know how to play off each other a little bit. So
that's probably true.
Yeah, yeah, it's just inherent. It's like built into our core now, essentially, of ways of triggering each other. Like if I mention anything about cars or mechanics, you'll go off on a rant every single time. So it's perfect. But yeah, let's jump in right away into what is JavaScript good at. So I mean, the core of this episode, like, just to go back a little bit, what can't JavaScript do, right? Like, that's the title of the episode. The reason I even say that is because this one time I was just sitting at my computer and I was trying to think of like, hey, what do I want to do? Like, what project do I want to work on? What side project do I work on? Do I want to learn a new language? And it always came back to the same thought of like, I don't really need to learn a new language. Like, I don't need it in my professional life. Like, at this point in my career or in my programming journey, I'm transitioning to more of a senior or intermediate level developer where I'm even reading more code than I'm writing some days. So like, I don't care about learning a new language just for the sake of learning it. I'll learn technologies on top of JavaScript because again, like I said, that's something I use every day. But just to go out of my way to learn a new language is not something that I want to do. Because like, I understand that it's not the end of the world. Like if I need to learn a new language, I will. Like if it's part of the job, like if I end up in a new contract where you need to, do embedded real-time systems, and I'll get to why JavaScript isn't a great fit for that. But like there's certain situations where you can't really use JavaScript or you shouldn't use JavaScript. And that's where this kind of thought process came into be. So in reality, one of the points that I have here is that 95, some people even say 99. These are made up statistics, by the way. It's just random. 99% of the time, JavaScript will be just fine for pretty much any of your workflows or any applications that you can think of, right? A lot of the arguments that people have with each other about, hey, JavaScript isn't fast, or hey, it's not secure, or whatever, that doesn't apply to like a regular business card website or a SaaS business that's selling subscriptions to their to-do app, or even their to-do app in general. Like if someone is creating a to-do list, they don't need the fastest speed of possible from a real-time processing language like Rust or C, right? Like they don't need that. That's not a necessity for a to-do list. And for, in fact, pretty much any application, any e-commerce application, anything that is just a consumer-facing app is usually going to be fine with something like JavaScript. So that's where again, coming back to it, that's where this kind of process came up, and that's where the thought process came. But I think it's important. I know the audience out there are mostly JavaScript developers, or you're starting to learn JavaScript. I think it's still important to know that it's not the perfect language, and it's far from it. And if you take a step back and you take a look and you start seeing the non-JavaScript crowd look at JavaScript, so the people that are coming from Java or C or C++, and you start a conversation with them saying like, oh, JavaScript's a great language, you're going to get hit, and you're going to get hit hard. Go on Stack Overflow or go on Quora and search for, is JavaScript a good language? Everyone hates it that aren't JavaScript developers. Everyone. And there's good reasons for that, I want to say. And there's also not good reasons for that. I think like most of it is bullshit, in fact.
I was going to actually ask you how much of this is, I don't want to say elitism, but because it really isn't that. I mean, some of it probably is, but trying to describe like when you start getting into something, like, so if you're like a tech guru, you start getting picky. You know, I like Windows because of this, and I'm sticking to Windows. This is why I love Windows. And you sort of, I guess it's more passionate about certain aspects of a piece of technology or certain aspects of something. And sometimes it's for good or bad reasons, but they are for reasons other than, yeah, like, screw you. Like, I hate this. You know, I hate the thing you're using. And it's like, why? Well, it's just because it's the way it is. You know, just because it's JavaScript, where there isn't a reason given. And so, like, someone who's like brand new to programming, or someone who's brand new to JavaScript, hasn't really developed that opinion yet. And so, like, I was just kind of curious in your thought, how much of this sort of, I hate JavaScript, is from these tech gurus, these programmers, these developers that have a reason, good or bad, versus someone that just is like, screw JavaScript. Why? Just because it's JavaScript, you know? What do you think on that?
I mean, there is a big, just because it's JavaScript crowd, like, screw JavaScript, just to say it, and whatever, that's fine. JavaScript, on the other hand, does the same thing. Like, JavaScript developers say the same thing about Python. There's this like weird meme war going on between the two. I don't think that's a serious thing. Like, no one's really, you know, hating Python, or no one's really hating JavaScript for just the memes. I think it's the people, like you mentioned, that have those serious, and I put serious in quote reasons, are the ones that we can kind of rebuke a little bit, or we can go at, and we can talk about, because although most of the time they're obviously saying things that are based in reality and based in truth, I think a lot of it is taken out of context, like, or a lot of it is taken to the extremes, right? So a lot of the time, and I guess screw the show notes, like, we'll just talk about this. A lot of the time, someone that's against JavaScript will say that, hey, it's very flexible and there's no real structure to it, right? So if I build a system, like a 24-hour system that needs to run all the time and is powering a human heart, it's not going to be able to do that because of the flexibility and the potential chance for error. And like, yeah, okay, that's true. Like, yeah, if I was building a system that was a healthcare system that needed to be up 24/7 or someone would die, JavaScript's probably not what I would go for. But who's building those systems? Are you actually building those systems in Java? Like, you're a Java developer. Are you actually building those systems? Are you a healthcare provider? Are you a doctor that's, also a software engineer? Like, I think people always take it to the extreme cases and do not acknowledge the fact that it's okay for everything else. That's where I think people need to step back a little bit and start looking at the wider picture. Because yes, there are situations in that 95 to 99, the 5 to 1% range that JavaScript isn't a fit. It's true, right? Whether it's because of the fact that it needs to be 100% available all the time and you have to rely on this, something that you need low-level code for, and I'll get into that a little bit later. Or whether it's something that needs to be extremely performant and every nanosecond counts.
I was going to say that is like with the performant angle, there's a reason why people use and used assembly or other languages that are quote unquote closer to the metal. and this all these arguments kind of just sound like they're using the correct tool for the job, and they just hate JavaScript even though it's a tool for, X job.
Exactly. And that's where it comes down to. And again, there's a lot of criticism back and forth, and some of it's personal preference. And that's something that I don't really care about. Like, sure. I mean, like in the sense that like you can have your personal preference, and that's great. And so can JavaScript developers, and that's great. But there's no reason to like destroy a language because of personal preference, right? Personal preference is a thing. And if you really hate JavaScript, you're probably never going to go around to it. Like you're probably never going to like it. And from people coming from traditional object-oriented programming languages like C# or Java have a hard time jumping into the scripting functional-based languages like JavaScript because it's just a very different paradigm. That's the reality. It's not as structured. There isn't this MVC pattern. Like there are patterns you can follow, and you can even make JavaScript into an object-oriented language, but you have to put effort into that kind of stuff, right? And they don't like the fact that they can go from one code base to another and have a completely different paradigm. And I 100% get that, especially in a larger sense, in the sense of like maintainability and scalability, maintainability in general. Like it could be a problem. But you can write good JavaScript code, good and structured JavaScript code. You can have set rules. There's software out there that can very much enforce those rules on your code base. There's ways to get JavaScript to be very, very rigid. TypeScript is one of those ways. There's ways to make JavaScript loose, but also a little bit rigid in the places that you care, right? Like you can customize that rigidity, that structure, however you want. And to some people, that's going to be a very big negative. And to some people, that's going to be a huge positive because you can have a little bit of progress. So maybe you can iterate on your structure, on your rigidity as you're going. As you grow your team, you need more rigidity. As you have less team and you're building a prototype, you can be flexible, stuff like that. That, in my opinion, is kind of the beauty of JavaScript, and where I really, really think it shines is the fact that you can build a quick prototype that's loose and flexible, and it's still clean code, but like it's not as rigid. And then you can take a team and scale that prototype to have all the type safety you need, all the testing you need, compile time, checking and stuff like that. Like there's many tools on top of JavaScript that you can use to make it as safe as you need it to be. I mean, there's a reason that I believe one of the rovers or something like that, one of the tools that they have is running Vue.js or something. Like there is a reason why JavaScript is starting to creep into all these industries that we never thought it would ever creep into. It's because tools around JavaScript have gotten so goddamn good and have progressed so much faster than the tools that are kind of saying than the older generation tools that are super, super rigid. Right? Because you can't build too much tooling around. No, go ahead.
I was going to say, this sounds so much like not the exact topics that we're discussing, but this sounds so much like someone who is justifying the use of WordPress. When someone is in an argument with somebody, a WordPress advocate, let's say, is in an argument with someone who hates WordPress, this sounds so much like a WordPress advocate going at it saying, no, see, like WordPress is extendable. WordPress is only the base when you install it. And they have a hosted platform, and you can bring it self-hosted with a different version of it, and you can download all these extensible things. And the one thing I thought of too was when headless CMSs were sort of kicking off, and one of those big questions like always pop up, like, hey, is this the future of the CMS? The WordPress people had it on lock, like, oh, don't worry about it. Just use WordPress like a headless CMS. That's kind of the same way I'm hearing the same type of arguments anyway. The same way you're talking about JavaScript. Now, I'm not saying that's good or bad, but it's just an observation that I've made where, the WordPress people love WordPress. You're going to be going into JavaScript. How much of this conversation, because I'll let you get into the technical specificities in a bit here, but how much of these sort of extendabilities and different tool sets that you've mentioned come from you justifying your use of JavaScript versus JavaScript is actually really good and should be used with these extendable tools, plugins, and frameworks.
It's a good point. Like let's be clear. I'm justifying my use of JavaScript, and I'm justifying the fact that I like it, right? Like it's my personal preference. A lot of what I'm saying is coming from that perspective. If we look at it if we look at it purely on statistics or speed or whatever, like we start to see JavaScript break down a little bit, right? Again, we're going to get into the fact that, hey, it's not super secure. It's not highly available. It's not as reliable as these other languages. It can be inconsistent. That's another big problem that could happen with JavaScript. That doesn't happen with every other language. I don't want to say every other language, some other languages. There's speed, right? Speed is potentially an issue when you're going with something like JavaScript, which is a higher level language versus something lower level like C or Rust. There are these, obvious facts against JavaScript that, stepping back a little bit, when I was talking about how much I like it and how much it can run on all these different systems and all that tooling, that I didn't take into account. And I did that on purpose because for all of my use cases, I'm not in the healthcare industry. I'm not in embedded system industry, right? I'm in specifically e-commerce. I'm in SaaS building. I'm in web app development, and I'm in web development. Those 4 industries, we're talking about what JavaScript is good at. That's where JavaScript sits. That's where it lives. Like, it's really good at that, right? Any sort of internal tool building that you need to do, any interactive user interfaces that you need to create, right? Interactive web apps, cross-platform applications that aren't too heavily reliant on native APIs. Anything in that category, which, again, if you go back to it, what are you building? Like, most of what you're building is encompassed in what I just described. And that's why it's such a powerful tool. Like, it's a great language because it's evolved. Obviously, it didn't start off at the highest note. It was built really quickly, and it had a bunch of faults. Then it started to evolve, and it's evolved to the point, with help from the tooling around it, I want to be clear, to be a very mature programming language that can work in all of these different cases. That's the reality. And that's why, like, it's really difficult to argue for it because, yeah, there's tons of stuff going against it. Yes, it's true. Like, it's absolutely true. So as soon as a Java developer or someone comes up and starts arguing, there's not much you can say other than the fact that it'll work. Like, JavaScript will still work for that. JavaScript will still work for that. And then until they say, like, oh, what about that 24-hour reliable system? It's like, yeah, you're right. It's not going to work for that. So that's it. Like, that's the argument. That's where these code wars tatter off. To be clear, there are other languages that fit the use case of JavaScript for the most part, right? There are other languages that can actually do a lot of what JavaScript can do. The one thing coming to mind right away in a similar way would be Python. Python is a great language that people can argue could go up against JavaScript in most ways. It can do backend. You can do some front end development with it, right? Like, you can create UIs for sure with Python. You can do a lot of analytical stuff, which is something that maybe JavaScript isn't as good at. So math and analytics, like, there is trade-offs. I don't want to say that JavaScript is the best language ever. That's not what this is about. It's more about, hey, I just like JavaScript and I've been using it, and I don't see any reason of not to use it for all of these applications that I'm building. That's the main thing. But we've kind of handled what JavaScript does well. We've touched on a little bit of what it doesn't do well, but I do want to put some structure around that right now. One of the main things I would say it doesn't do too well is structure, in fact. And I mentioned this a little bit with, like, something like coming from object-oriented, more structured languages that have a very clear pattern of how to do things, right? Like, this is how you build a UI. You get a decorator. You have the MVC approach. You have, the constructor. Like, you have very clear patterns and algorithms to follow to do certain things, right? JavaScript is very much the opposite of that, where you have any of the of the above systems to build whatever you want. And on the one hand, I like that personally. Like, I really like that because I think it helps JavaScript evolve and it helps new systems be developed and it helps like these frameworks that I talk about all the time just get better and better with time and have more structure around them. But on the other hand, coming from a person that's just coming into it and needs to maintain maybe 20 different applications in JavaScript, it's very feasible that all 20 of your applications could be using completely different systems, let alone frameworks, let alone patterns, let alone architectures, whatever, because JavaScript allows that. It's extremely flexible. And again, that could be a maintainability nightmare for some larger corporations and some larger companies. That's the perspective that I'm seeing that from.
Well, the one thing here actually to bring up is one of the big problems, I'll bring WordPress in actually as an example. One of the big problems with WordPress, and you, the listener, can agree and disagree with me, and same with you, Mike, as well, is that stuff is kind of everywhere or could be anywhere. A plugin might make a separate menu that allows you to access it from either the sidebar, or you have to go to the plugin screen, then select settings, and then you have to go into that settings screen and set a value there, and then you save it. Maybe the plugin has you enter in values into fields that are vanilla JavaScript, and it changes them so they act differently. And you can have conflicting plugins where they both do the same thing, and one's fighting for the control over that certain thing. That type of problem in WordPress is often what leads to problems. The white screen of death is what it's known as, or the WordPress screen of death, whatever it is. When WordPress is just straight up having a problem and effectively can't boot up. It can't run like it's supposed to. And with JavaScript, you kind of, let's just bring it down to vanilla for the sake of conversation. With vanilla JavaScript, you don't have your plugins and stuff like that because we are at the vanilla level, but it is a little less structured than what you might expect. Now, I want to be clear that I've only really programmed in assembly, in JavaScript, as well as maybe the odd framework here and there, but also C and no, I think it was just C that we went with, and maybe C++ a tiny bit when we were programming like little circuits to like turn off and on LEDs and stuff in school. And when we were doing that stuff in C mostly, everything was very structured. There was, here's your files that you make up, your core files that are effectively your driver. They're separate. And oftentimes they're separated into their own files. This stuff does the LEDs. This stuff does the general input output. Very structured into files, very structured code inside of those files. And then you put it into, we were just using a visual IDE because we were learning more about the circuitry and stuff, but some people would do it from the command line. But at the end of the day, this structure allows you to tell a compiler to compile the code up, and then in our case, load it onto a little chip on a board. With vanilla JavaScript, you don't have to compile it or anything, which makes it useful, but you can have JavaScript all over the place. Not in as many nooks and crannies as, say, WordPress, but it really depends on the website. Some websites do have a lot of files, but they don't need to be as structured as the ones I just discussed with C. They can just kind of be everywhere. They can be named as like a bunch of different things. We've made sites in the past where the header is really complex for whatever reason. It's just a huge header, and it has tons of HTML and tons of stuff that has to be in there. It's just a massive header for like a really big nav bar for like an event or something. And so I'll put that in a separate file and just sort of import it in, or PHP it in, or whatever, like, display it with PHP inside of the main sort of file, the index file. With JavaScript, like vanilla, your JavaScript can be anywhere in indefinite, or yeah, I'd say indefinite amount of files. Obviously, disk space and stuff is going to become a problem eventually, but you can have a file called like hello, and it might do the goodbye script. You can have that in a folder called JavaScript, or you could just have it in a folder called JS. You could have it in a folder called hello. You could have it in a folder called PHP. You don't need, it could be anywhere. This is on top of the fact that JavaScript can be done straight in an HTML file as well, for example. You have your index.html. Let's say you're just doing a vanilla site, HTML, CSS, JavaScript. This is, again, nooks and crannies where your JavaScript might be in line inside of your HTML. It could be partially in your HTML. It could be partially inside another file. It could be scattered among the HTML and several other files. So whereas, again, it's not as sort of nook and cranny, like there's not so many different crazy areas that you could kind of hide stuff like in WordPress. Like I've found CSS in the craziest places in WordPress where I'm like, why is this just not styling? And it ends up, I spend 4 hours looking around and it's in some random settings file that was only for this theme. And it's only in just some really random file. Maybe not as in depth as WordPress, because WordPress is pretty chunky because it's older and has a lot of support for older systems, but it's still the same vein. And when you start adding different frameworks and stuff, you start adding a compiler to the mix usually. So maybe some stuff has to be structured, but a lot of these frameworks that you add, or a lot of these frameworks that you can use, support just vanilla JavaScript. So you can have a double whammy there, where you can have JavaScript done in the way that, say, a framework is meant to be done using the framework. Let's just say just some JavaScript, some frameworked JavaScript, if you will. And then you have some vanilla JavaScript hiding in that same file, or hiding in another file across somewhere else, or a remote JavaScript file from somewhere that someone's calling in. So I think that maybe this is where some of the hatred for JavaScript comes in, because when it comes to that stuff that we were doing with the circuitry, where you have your C file, I'm going to code this up and I'm going to code it so that when I click this button, it's going to detect that the voltage was cut for a moment. And that means I push the button and an LED is going to light up. Everything's done right on board. Everything's done right on the computer. Everything's done in its own files. Surely you could probably have a messy directory to an extent, but a lot of it needs to be structured in a certain way, coded in a certain way so it'll compile. It compiles it, throws it on the chip, and that's it. So this is kind of where JavaScript may lose some people, because it really can be hidden in random places. It really can be just easily called in. If I have a JavaScript file on a server, just a random server, I just buy the cheapest shared hosting I want, and I just host a random JavaScript file in there. And then I have my site hosted on a totally different hosting service. I was going to say allegedly, that's incorrect, but as long as there's no blockage, like a firewall blockage between the two hosts, I could just call in that other JavaScript file with one line. So this is where JavaScript can kind of fall into the same trap of being a bit of a mess, the way that I see WordPress sometimes getting in trouble.
Yep. That's true. I mean, exactly what you said. There's just a million different ways you can do something in JavaScript. Now, I do want to be clear that other languages can suffer from something like this. I think JavaScript is on the extreme end, where there's a lot of different variations, but even mobile app development, I've personally witnessed this, where I came in and I was trying to figure out how an app was working. And I believe it was an iOS app, and there was Swift code, there was Objective-C code, as well as C++, all mixed in with each other. So that was a bit of a mess, right? So I have experienced this outside of the JavaScript ecosystem. I just think it's less likely to happen, right? Like, it's just less likely to happen. So you can definitely jump into a Python project, and have situations like this. There's probably, Python is actually a very good comparison to JavaScript, where it's very flexible and it does have a little bit less rigidity. But again, JavaScript is not the only one that has structural issues. That's all I want to say. But I have experienced some serious problems taking over a project or consulting on projects that have been passed from developer to developer in JavaScript, because again, every developer, unless there's a rigid system in place, will do something slightly different. And that could cause a lot of maintainability issues down the line. Now, another issue with JavaScript could be high availability and reliability. Because JavaScript is a runtime scripting language inherently, it does not compile down to machine code before you run it on the browser. It'll actually run on the browser, and at that point, it can error before you even know it's going to error. Bad way of saying it. Essentially, what I'm saying is that a lot of compiled languages will catch errors in your code, or will catch like an infinite loop, or will catch that, hey, you wrote this incorrectly before you even put that code onto whatever device it's going to be running on. That is not how JavaScript works. JavaScript will let you put the code that's broken, and that could eventually could even cause an infinite loop and run out of memory or whatever, like memory leaks, and let it run, and you can catch those errors in your browser, or you can catch those errors in runtime. So it can have issues with reliability, because if you think about it, yeah, you can run through your typical test cases. There's plenty of testing libraries for JavaScript. That's great. But what on an edge case? What if you miss, like, hey, if this and this is true, and then and this is true, and you're pulling this data in, all of a sudden that's an infinite loop, right? In this particular function, it would never catch that on your testing libraries. That will only be caught when it happens in real life, like in production.
You're left effectively to troubleshoot both the logic of the program and say mechanical problems.
Exactly. And again, there is tooling to help you with this. And I say help because I don't think it's fully solvable. TypeScript is one of them. It can make sure that you're passing the right types back and forth in all of your code. It can also check to see a lot of structural stuff as well. There's linters, right? There's ESLint, which can set structure in your code and make sure that, hey, you can't declare this variable before you use it and stuff like that. There's a lot of rules you can put in place to help bring these problems down to a minimal likely scenario, right? Like there is a way to make JavaScript safe, but you have to put all that in place. And again, if you pass a project on to another developer and they pass it on to another developer, the chances of them changing those rules or using different rules, it keeps increasing and increasing. And that's where errors can come into play. And that's where serious production errors come to fruition and stuff goes live and takes down production or deletes the database or whatever. So it can definitely happen. Consistency is the next one here. Because JavaScript relies on many different engines, so many different runtime environments, like I was talking about before, to run it, you can't have inconsistencies across them. So there could be JavaScript code that you write that runs perfectly well on Chrome, for instance, but has issues with a race condition or with inconsistencies or whatever on Safari. Because how these engines compile down that JavaScript and use it to run their browser is slightly different. And in fact, some of the APIs that are exposed in JavaScript are also slightly different engine to engine. Now, it's gotten 1,000 times better than it was even 10 years ago, where we had Internet Explorer, where we had Opera, where we had, 10 different engines out there, all competing to be the number one engine and choosing to not put features in that the other engines have developed just to be a competitor and making their own version of those features that are completely different. Like there was this crazy war going on at the time. It's become a lot more cohesive now, but there's still like the Safari versus V8, right? Like the WebKit versus V8 discussion. There's still Firefox. There's still kind of that competition, and there's still issues with inconsistency just based on where you're going to be running the code. So if you need your code to run the same on every single device, JavaScript might not be for you. Having said that, again, there's not much like what is the device that you're running on? Like if it's an Android phone all the time and you need it to run exactly the same on the same exact Android phone, then yeah, maybe building it in something like Kotlin is a better move, but it's a tough situation because I don't know too many situations where this would apply, but it is a problem. So it's that edge case, that 1% edge case that could potentially lead to a decision of not using JavaScript. That's why I wanted to bring it up. Next thing here, speed. and probably one of the more important things that people like to point out. JavaScript is a scripting language. It's very high level. It is inherently not going to be the fastest performer out of all the different languages. Just reality. That's the truth. Now, there are great JavaScript runtimes that make stuff a little bit faster. I know Safari's runtime WebKit is very efficient. I know there's some backend platforms for JavaScript like bun.sh that just came out that runs crazy fast and even competes with some lower level languages. Somehow I haven't dove into it too far, but I'm really curious to try that out. But let's put those aside. Those are bleeding edge new technologies, essentially, like the bun on the bun side. In reality, JavaScript isn't the fastest performer. In most things, it's just average. It can do the code. It can run the code, no problem. It's not super slow or anything like that. Like, you're not going to be clicking a button, waiting for 5 seconds for something to happen. It's still using your modern processor, your modern phones, and those phones are sufficiently fast to run pretty much anything you would want with a JavaScript engine. But again, when you're going down to the nanosecond and you need stuff to process super quickly, like, for instance, I would never use JavaScript to code a airbag detection engine, because when a car hits something, if you have JavaScript going all the way up to the high level and then all the way back down to the low level, that inherently, just that back and forth, is going to introduce enough latency that's going to make the airbag very inconsistent. No one's using that.
Especially if the system's busy. You know, especially if that system is busy, if that computer is busy. We all see websites lag out when they try to render something. Sometimes that's due to JavaScript, because your computer might be doing something completely, like rendering a video in the background.
Yep, exactly. It's just like, you don't want to inherently utilize many different layers of compiling code to do something that's life critical when you need it in an instant. So again, the stuff that I'm talking about right now is in the very 5 to 1% use case, right? Like I mentioned before. Like, you're most likely not, like, as a web developer, you're not going to be building life critical systems. It's just the reality of the situation. You're not going to be. You might
should
be building
probably
secure
be having
systems.
a professional there too that's used to it as well, especially if it's actually truly life critical. You should probably have a senior dev that has a lot of experience with life critical systems, because it is life critical. If you want to play with it in a completely prototype, not actually life critical environment, pretending that it's life critical, I mean, go ahead. But when it comes to an actual, something like an airbag deployment or a medical device, I would highly recommend you get an actual professional in there.
Correct. And also recommend that you have multiple safety audits from multiple separate agencies that do these safety audits on a daily basis. Like, there's many different things that goes into these life critical systems. It's not just like, hey, let's hire Bob and hope that everything works out. At least I hope not. I mean, the ones that I've personally talked to that have built systems like this have told me that it is a pretty rigorous process, and there's always audits. And I think the audits are the really big keys here. So you get a really good developer to develop really good software, and then you get really good auditors to audit that software and make sure that the developers can fix it and maintain it and stuff like that. There's a lot that goes into it. You're not building it with JavaScript. Just not going to happen. The other thing is that with speed, like in the speed conversation, JavaScript is not inherently multi-threaded. So it's not going to split your code into multiple threads and run it on multiple threads and then, combine it back into a single thread when you need it. You can do multi-threaded JavaScript, but it's very manual. Like, you have to run a service worker, and it's not something, I say it's not something that's predictable, but you can't, I believe you can't target a specific thread at a time, and you can't really rely on I don't know. You know what? I'm not going to say it because I'm not 100% sure on this. I haven't done service worker stuff in a few years now, so I'm a little bit out of the loop. So just know that it's not inherently multi-threaded. You can do multi-threaded work, but you have to manually do it. Like, you have to purposely build out a multi-threaded system using service workers and implement that system in your code. It's not going to help you do that. So when your web page is running, it's usually running on a single core. And I think every process, so every web page can run on a separate process, and those processes can then be multi-threaded. And that's how service workers also work. They just spin up another process that the your CPU can then take and put onto a different core, right? That's how it works. So like multiple tabs will run across different processors, but a single, when you're loading your web page, it's going to run on a core. Whereas a lot of other languages will help you with the multi-threaded aspect. So if you're doing a bunch of, animation compiling and animation rendering, especially in terms of video game development, right? Where you need to use something like CUDA cores to render out different scenes, different 3D models and different pixels and stuff like that. That should all be multi-threaded. With a JavaScript gaming engine, although they do exist that help you with the multi-threading, it's just a lot harder and it doesn't make as much sense.
I guess the thing with something like gaming is when it comes to, say, what they call AAA gaming, for those that don't know, AAA gaming, those are generally the top of the line games made by huge studios, millions of dollars in budget, the whole shebang. Because of that, it's usually state of the art tech. And so, of course, they're going to have a whole bunch of systems in there, little tricks to make things run better. They're going to be pushing that hardware, console or PC right to the edge. All that sort of thing. But I guess with a JavaScript runtime or a JavaScript game engine, let's just hypothetically say for the sake of conversation that it is running on one core. Thing is that cores are getting better. And if you're just doing like a tic-tac-toe that like flips around a little bit or something in 3D kind of, that's probably okay.
Yep. But
if you're rendering a whole scene and you have to remember something, these scenes are, say, an open world game where there might be 50, you're in the forest, so there's 50 bushes and 30 trees in front of you, and each one of these leaves is doing something. They're all moving based on the wind. The one tree is not moving like as if the wind is going north to south, and the other one's going as if the wind is going south to north. There is a hell of a lot of calculations and a hell of a lot of stuff going on. So in general, web dev to game dev, it's a totally different finished product, usually, than you'd expect. I have seen tutorials on YouTube of not even game engines, of people using just vanilla JS and Canvas to make some pretty cool looking games. But that's because modern computers, in general, can run things pretty good on one core. But if you were like, yeah, I'm going to make the next Halo is a common enough one for people that don't game. I'm going to make the next Halo in JavaScript. Maybe, but I don't think so. I personally don't think you're going to do that.
Yeah, unless you use like a Unity for JavaScript thing that handles the multi-threading for you. Like there are ways around it a little bit, but it's not going to be as performant as like a lower level engine for gaming. So like it's one of those situations that, yeah, you can use JavaScript, but would you? That's the question, right? Like if you're building a casual game, yes. If not, then you're probably using an engine.
Yeah, definitely.
And just to jump into the summary of this section, right? So where wouldn't I use JavaScript personally? And I don't have the answer for everyone out there. I just have the answer for myself. Mission critical, real time, 24/7 operation systems. So, right, embedded systems. I wouldn't use JavaScript for that. Just reality. High availability backend services that need to be very fast. Process requests instantly. I would not use JavaScript for that. Yeah, look, we just talked about large games, AAA game titles that require very high fidelity graphics. I would not use JavaScript for that. So, having said that, again, those are the three cases that I can think of. There's probably more, but those are the three cases I can think of where I wouldn't use JavaScript. Again, I think that my 95 to 99% still applies because everything else I would use JavaScript for because I'm most comfortable with it and it can do it without too much of a problem. So I wanted to give both sides of the coin as best as I could from a biased perspective. Because I think it's still important as someone that's biased or as someone that likes something to look at it from the other end and be like, okay, what is it? What are the problems with this? Because there are. Nothing's perfect. JavaScript is far from perfect, that's for sure. But yeah, so hopefully that can help you hopefully you're not getting into too many arguments, but hopefully it can help you in your arguments with people that shit on JavaScript all the time, or hopefully it can help you avoid those arguments because it's probably not a worthwhile time investment. Or it can help you maybe make that decision in your work, being like, hey, we need to build this real-time system, and then you can avoid using JavaScript for that. But I did want to kind of end this episode on alternatives to JavaScript. And here I'm just going to talk about like different coding languages, just touching on them a little bit. I'm not going to go too deep because I haven't used most of them in a very long time. Because again, I've been very focused on just really diving into JavaScript and making sure that I'm as versed in it as possible. But yeah, let's jump right in. On the web, really, there's no serious alternative to JavaScript at the moment. There is something like WASM Rust, where you can do high performance applications. Stuff like video encoding can be done using Rust on the web. So there is a case to be made that there's some value in learning Rust if you are a web developer that wants to work on high performance systems. Stuff like PHP, you can do a lot of logic. It's server side for the most part, but on like the balance is there where like sometimes you don't need the client side rendering or you don't need the client side stuff. So you can do a lot of what JavaScript can do with PHP. Python, there's plenty of web frameworks that use Python where you can do a lot of JavaScript type stuff like DOM manipulation, like server side rendering stuff. Again, Python will be more running on the server, but it can emulate a lot of what JavaScript can do, just like PHP. There's also something that's more kind of bleeding edge that I wouldn't fully recommend at the moment, but it's something to keep an eye on, would be Flutter Web. So that is something that can run in the browser, as a front end. It's one of the only ones that can do that, that can run client side and build UI interfaces on the web for websites. It's using a language called Dart. And the issue with it right now is that it's still early. And a lot of SEO stuff isn't working perfectly. Some of the UI interaction stuff you have to kind of build yourself because it's essentially kind of like a canvas or a game engine that you could put UI elements onto, right? So that's how you have to think about it. The browser doesn't understand it inherently. So you have to tell the browser what each element is. So although it has potential and it's a unique case, it's not something that I would say is an actual alternative to JavaScript.
I will say one thing too here, that this is not an alternative. I want to be clear. This is not an alternative, but CSS does have a little bit of logic that it can do. There's variables and stuff now. There's things where it can, change the style based upon what a custom property is changing to, which may be manipulated by JavaScript. So maybe it's a JavaScript and CSS in tandem there. But there are CSS gurus out there, more specifically, that do some interfaces solely in the HTML and the CSS, things that some other people would possibly do, like, let's say, a more complex version of a hover control, where they want to have a hover control with the mouse, if the thing's being targeted, if the thing is, mouse up, mouse down, this and that and the other thing. Some CSS gurus can get pretty advanced, like they can do some pretty advanced CSS to sort of do some of these things. They can get into certain media queries coupled with. I'm not a CSS guru, so I don't have exact examples, let's say, but I know that when Mike and I were coming up, we would be doing some hover effects, and let's say we needed something very specific for hover effects, so we ended up going to JavaScript, and there were people in Stack Overflow and such that were like, here is it in just HTML and CSS. And so that's sort of more cutting edge JavaScript. It's sort of more, cutting edge CSS. It's more, the guru understands all the ins and outs of how CSS understands things, or like what is even possible in CSS. And instead of just thinking of, this is a logical part, I'll reach for JavaScript. Some people will reach for the CSS. I want to be clear. This is not an alternative to front end logic, but depending on how simple your project is, some advanced CSS can handle some logical tasks. And I want to be clear with the some, but it's getting there.
Absolutely true. I think that's a really good point. Always use the least the tool that is the least complex. So again, if HTML can do it, don't use CSS. If CSS can do it, don't use JavaScript. That's the rule that I always use. And let's talk about backend. So again, JavaScript can do this, can do backend with Node.js or Deno or Bun.sh now. You can do a lot with JavaScript on the backend, but there are alternatives. PHP is one of the main ones. It's still a very dominant force on the web. There's still plenty of work in the PHP space, and it can do some things better than JavaScript. Like it can run in certain situations better than what JavaScript can do. I think performance is pretty close and on par, but there are certain situations that maybe multi-threaded situations especially can run a little bit better on PHP. Python. Great choice for a backend language. Honestly, it's very flexible, just like JavaScript. It can do a lot of data analytics right out the door. It can do a lot of math. You can do anything with it, really. Like, again, very similar to JavaScript in that sense. But Python is a very highly in-demand language and very highly successful one. So it could fit into a lot of backends. Go is one that Google developed. I've just dipped my toes in it a little bit, just kind of more reading than writing it, and just maintaining it. It's looks pretty great, honestly. Like, it performs really well from what I've used. It has a very structured approach to it. It is a solid language that seems to be taking off in demand. I've listened to people rave about it all the time. And I think it's something that people should look at if they're looking to a more back-end developer role. Mobile development, you can use something like Swift for iOS or Kotlin for Android. Those are the native languages that run directly on the mobile device. They're the highest performant ones, right? Or if you want to do cross-platform development, you can use something like Flutter, a Google-developed system. I was talking about Flutter Web before. That's not as mature. Flutter for mobile, so building one code base for iOS and Android, is mature at this point. You can definitely build great experiences, great user applications that are very performant. That's not to say that JavaScript can't do that. JavaScript, you can use something like Cordova or React Native, no problem, to build a mobile application, compile it, put it on the Play Store. It's totally possible. But there is some argument to be made between the two, between something like Flutter or React Native, where sometimes I think Flutter can be a little bit more of an advantage and sometimes React Native can have some advantage, right? And then obviously if you go down to Swift and Kotlin, that's a totally different story, where like if you need something to perform and act like a native mobile application as close as possible and be maintained by a native mobile application team that accesses a bunch of the core APIs of the device, then maybe you go that route, right? But it is up in the air. I think, again, the 95% rule applies. You can definitely, in 95% of occasions, build a mobile application using a cross-platform technology, whether it be React Native or Flutter. Desktop applications, you can use something like C# for any Windows application or Swift for any macOS application. So both great languages. C# is a Windows-based programming language. I was actually the first programming language I ever used. And it's very, very much object-oriented. It's like Java, but a little bit more mature from what I can see and from what I can remember, honestly. Gaming. So surprisingly, like Matt was saying before, that game engines are like the bleeding edge technology because they need to utilize all the little new pieces of your hardware as much as they can. The weird thing is that gaming programming languages are still very much reliant on C++, it seems. Now, I'm not saying that all of them are, but a lot of game engines still use C++ at their core. So when you're developing games, as I've talked to other game developers, a lot of them are using C++ still, which is interesting, but that's something to know. Like, if you want to,
is this a driver thing?
I don't know. Maybe,
you know what I mean?
I don't know. Maybe it's a driver thing. People don't want to like compile it, down to C++ instead. So just lose that little bit performance. So people are just like, whatever, we'll just build with C++. I think a lot of it. I more
so mean that the hardware, like the GPUs, the CPUs, and God knows how many get more custom chips on different laptops and such, would have certain let's just say APIs, but endpoints for developers to use. I was just wondering whether, because you have, let's just say Windows for the sake of conversation, we'll leave Mac out of it for a second, but it's like, because you have Windows and you have to support so many old things, and then you have these new pieces of hardware which are being put into Windows, which needs to support all these old things. The driver might have to be a little bit older. And so you're using C++ because this is 100% speculation on my behalf. I'm going to tell you right now, but I wonder if it's because C++ is so commonly used in Windows that it's like a common language they can use to access that hardware's power. Because the driver and everything might be all like super, I don't know, efficient at using that. I want to be clear. I don't do this. I'm just speculating.
Yeah, I don't know. It's a good question. I actually wonder that myself, why we haven't evolved from C++ on the gaming side. Maybe it's just because C++ is fine. I know Google actually recently released a C++ competitor that builds on C++ a little bit and can do everything that C++ can do with the same kind of performance. So I guess that's maybe the next step. But anyway, like I think people just like C++ and it's fine for what they do. Most of the stuff is handled by the game engines, right? So the C++ that you're writing is probably not too crazy. Unless you're writing your own custom game engine, which I've seen people do, which is insane, but people do that. But yeah, like it is what it is. I don't have any experience with C++, so I couldn't tell you. Next thing is embedded systems. So this is something Matt and I do have some experience with. This is something we went to school for. C is probably still the main one. For me, I would probably look at Rust right now as well, because that language is kind of taken off. And I feel like it's going to be a pretty significant part of not only web development, but any low-level system down the line as well. So it's a good kind of language to know. I know even Web3 blockchains like Solana are running on Rust. There's other ones that are running on Rust, or you can build smart contracts with Rust, I should say. So like, yeah, that's pretty much it. Like, I don't really have any too deep dives into these alternatives. I just wanted to kind of bring them up just so people know that there is something out there in case you're just learning JavaScript and you haven't had your eye on the programming language market. There is other stuff out there, whether you need to learn it or not, depends purely on the job that you get or the path that you want to take. Like if you want to be a game developer, maybe C++ is the way to go. I don't know. But yeah, that's it for this one, I think. Matt, anything else you want to add?
No, other than that, what you were saying, if you were to say go to become a game developer or you want to become a desktop app developer, and you want to learn you want to get a job, just look up what the job postings are asking for is probably a safer bet. If they are asking for C++, great. If they're asking for C#, great. Just kind of go with whatever the job you would want is. Basically choose a company that you'd want to work for, choose a position in that company that is open and has a job opening, and look at what they're asking for. And then you can kind of base your learning on that and go from that is kind of what I would recommend. Because I mean, I would look at multiple places. I wouldn't just look at one company. That would be like a good place to start, and then look around, because maybe that one company is using C# and everyone else is using C or something. But, to get a feel for what languages are being used in the industry at large, look at the industry at large is a good way, I would think, to do that. But like Mike said, it is time to end. So thank you for tuning in so far. And remember, we are on that Patreon. That's patreon.com/HTML, all the things. And thank you to $3 tier patrons. Ryan Gatchell from Blue Black Digital on blueblackdigital.com. Chris, the self-made web designer on selfmadewebdesigner.com. Tim from the Web Hacker on thewebhacker.com. DL Ford from dlford.io. Bib Hashdash from 9block Media on 9blockmedia.com. Jason from Geek Life Radio via geekliferadio.com. Michael Curie from MC Web Studio via mcwebstudio.ca. Magnus from YesWeb via yesweb.se. Jeff from Twitter via @theJeffMcHale, and Fire Ant Season via fireantseason.com. Feel free to leave a comment or a review in the platform that you are listening to this on. And this outro will sign us off.
You've been listening to HTML All the Things podcast. Web development, web design, and small business. We hope you've gotten some useful and practical information from this show. And we hope you appreciate that we talk to you like human beings. And we hope you had some fun. We'll be back soon. But in the meantime, hit us up on social media on Facebook, Instagram, and Patreon at HTML All the Things. And on Twitter at HTML Everything. Until next time, this is HTML All the Things, signing off.